intergenerational conflict, I will go very fast, but please interrupt me, because I don't know what you know about that. Often is done cost-benefit analysis. So the first step is understanding the effects, and the second step is assigning monetary values. But then we have an issue. For instance, suppose that you have those two projects, projects A, projects B, and this is the estimates of cost and benefits. Both of them requires an initial cost of 20, and then those are the cost and benefits in the different years. This is, for instance, in this 5th year, project A gives 8, and the other one gives 6. So the problem is how to compare those two projects. As you know, it is important the net present value. How much is $6 in 5 years today? What is the value of $6 in 5 years time? So we can divide each value by the discount factor. I guess that most of you knows this stuff. And then we can sum all discounted values. Of course, net present value depends on discount rate. And which is the discount rate that we have to use? Depending on the net discount or on the discount rate, we have different net present values. For instance, what about if the discount rate is 0 and you have 7 and 4? What does it mean, 7 and 4? It is just the sum of the costs and the benefits. If you do the sum of all that, you get that for the first project, you have minus 20 plus 10, which is minus 10, plus 8, which is minus 2, plus 9, which is 7. So the sum of all cost and benefits is 7 in one case and 4 in the other case. So if we don't use a discount rate. And so we can repeat this for all the discount rates, and then we have these two different profiles. You have also another concept, which is the internal rate of return. Internal rate of return, which is 5% in case of this green project, or red in case of 9% for the red project. And of course, but this is not the issue, is that if we use 3% discount rate, what would be our assessment? If you use that for low discount rates, lower than 3%, for instance, 2%, A is better, project green is better than project red. If you use, for instance, 4% discount rate, then the red is better than the green. And if we look at the temporal profile of the two projects, you discover that the benefits of A are far in time. If you look at the temporal structure, okay, we have a project A who has a big initial cost and benefits in the future. We have a project B that has a lot of gains at the beginning and then some cost at the end. And typically, when you have a nuclear plant and you have this decommissioning, the commissioning is the dismantling of the nuclear plant. But perhaps this is in 50 years. And suppose the cost is very high, maybe 100, but then you have to divide 1 plus the discount rate to the 50, which becomes very small. But who has to pay for decommissioning? I will not pay for decommissioning because in 50 years I will not be alive. I will not pay taxes. Okay? So the issue of discounting is crucial because the higher the discount rate, the higher is the inequality problem, the intergenerational problem, the problem of equity between generations. Okay? So using discount rates, there is, a discussion on that, but in general, using discount rates is an advantage for present generation. And why shall we use a discount rate? We have two ideas. One is the opportunity cost of capital, which doesn't want to show up in this slide. That is, I can use the money, the opportunity cost of using the money. The other is the idea of time preference. And so the discount rate usually is specified as follows. There is a component, which is a utility discount rate, individual, which is based on pure time preference, impatience. Usually we are impatient as a private individuals. And then we have a survival probability. At the same time, we have also the elasticity of marginal consumption of marginal utility of consumption and multiplied by per capita consumption growth rate. Why is that? This expresses the idea that of economic growth. In the future generation will be richer. But if the utility is, the marginal utility is decreasing, this is the utility, so there is this idea that the richer I get, the less is the utility that I get from $1 of income more. Okay? So the idea that I do sacrifice, I do investments today, and then people in the future will be rich. So for them, money will have less value. And because of this, it is ethically acceptable to give a premium, to give a price to present generation, and to give a lower value to the money in the future, because people in the future will be richer than today. And this is this idea. If you substitute, so this is the elasticity of the marginal utility of consumption, and this is the growth rate. And of course, in public choice, in decision about policy, in policy decision, we cannot consider this as ethical, because also other people will come in the future. So we cannot say I want to discount because I prefer to have an egg today rather than a chicken tomorrow. But usually this is a main argument for discounting. But the real issue today is that we don't know about the future. yes, maybe we will have economic growth, but if we are destroying the planet in the sense that we have increasing environmental damages, increasing extreme climatic events, and so on, and we are not at all sure that future generation will be richer than today's generations, or will have more utility than today. So a big problem in public policies and in project assessment and in decisions about progress, about programs, is using a time discount. There are some economists that say that it could even benefit future generations. There was a huge debate. So things are not so simple as I told you today. This is the issue of discount rate is very important, and usually it discriminates against projects that are more related to environmental protection, environmental conservation, and so on, because usually the economic benefits are we can have economic benefits very quickly, and usually the cost from nature and from the environment comes in several years, because of course nature and humans have different time scales.